So you don't need to know a lot of math to be able to understand the solution to this calculus problem right here. Matter of fact, you'll be able to understand a very fundamental concept of calculus as long as you know some basic math and a very little bit of algebra. So I'm going to explain this calculus problem in such a way where pretty much anyone will be able to understand it and more importantly, have an appreciation for calculus and why we need it. But before I get into all of that, for those of you that do know some calculus, or maybe you took this many years ago or took calculus, 20, 30, 40 years ago, let's see if you can remember how to do this simple calculus problem. All right, so I'm not going to tell you what it is, but the answer to this problem is over here. So A is 1.5, B is 6, C is 50.2, and D is 19 over 3. All right, now feel free to use a calculator, but if you can figure this out, go ahead and put your answer into the comment section. Then, of course, I'm going to explain this calculus problem, how to do this calculus problem in such a way where pretty much anyone can understand, and more importantly, where everyone can really have a good sense of why calculus is so awesome. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoyed this content, make sure to like and subscribe, as that definitely helps me out. All right, so what is calculus? Well, in real kind of basic terms, matter of fact, let's just do something here real quick on when you actually take calculus. Who takes calculus and why do you even need calculus? Well, typically let's go back to like our high school days. So for most students, they take algebra at the 9th grade level, and then at the 10th grade level, they'll take like geometry, and then 11th grade, like algebra 2, and then 12th grade, typically like pre-calculus. Now, some students actually take calculus. So calculus is typically a college level math course, and not everyone needs to take it. People that generally take calculus are those that are going into some sort of engineering, science, math type of major. Okay, so if you've never taken calculus, well, you very well may have no need to learn calculus. But calculus looks very mysterious. It where you have symbols that you only see in calculus. You don't see these kind of symbols in geometry or algebra. But remember, math is a language, okay? Like any language, if you don't understand the language, the symbols are going to look kind of funny and crazy. All right, but this particular problem is really an area problem, okay? We're trying to calculate the area here, and what we're going to do is calculate the area that involves this thing right here. Now, as I promised, as long as you have some basic math skills and some basic algebra knowledge, you'll be able to understand this. Don't give up, if you're lost right now. So let's get into the main concepts of this problem. So we are talking about area. Okay, now what do I mean by area? Well, let's suppose I said, hey, find the area of this rectangle. Okay, and you're like, well, I could do that. So we have the length and the width. So how can we find the area of this rectangle? Well, you might be saying to yourself, well, don't I just need the formula? So yes, indeed, that's right. The area is equal to the length times the width. So if our length was 10 and our width was 5, the area of this rectangle would be 50 square units, right? So maybe if this was like meters and this was meters, we would have 50 meters squared. All right, so the main idea here is that to find the area of a figure, as long as we have the formula, we should be okay. So let's find the area of this circle. Well, we can do that as well, but we need the formula. So the formula for the area of a circle is pi r squared. All right, so how about this triangle? Well, indeed, we can find the area of this triangle, but we need the formula. So the area of a triangle is equal to 1/2 base times height. So some of you might be saying, well, hey, Mr. YouTube Math Man, I can find the area of anything as long as I have the formula. Well, that's pretty good logic. Unfortunately, that's not the case, because what if we had this crazy looking figure right here? So you might be saying, well, I don't even know what this thing is called, but if you give me the formula, I can calculate the area to this crazy figure right here. Well, unfortunately, there's no formula that goes to this figure. So you might be saying, well, how are we going to find the area? Well, calculus is going to be our kind of hero. And calculus, a huge part of calculus, is helping us find the area and volume of crazy shapes that we don't have a formula for. Okay, so I'm kind of obviously simplifying this. So for those of you that know calculus, or maybe you are a professor of mathematics, you're like, hey, well, you're not talking about this, that, and other thing. Well, remember, I'm keeping this at a very simple level. So again, one of the main things, main type of problems that calculus solves for us is to be able to find the area and volume of shapes and figures that we don't have a formula for. So, kind of like non-standard, basic shapes, something like this. How can we find the area of this thing? Well, let's talk about this right now. All right, so one of the main concepts of calculus is, again, to find the area of oddball shapes, but really, well, let's just think about how we can maybe get a pretty good estimate of the area of this figure right here. So some of you might say, well, I know how to find the area of a rectangle, right? So the area of a rectangle, whether it's this way or this way, is the length times the width. So I could just get a rough estimate of the area of this thing by just going, all right, well, here's the length, here's the width. I can at least get this much of this shape, right? The area. We can calculate it out, but that's not a great estimate. But what if we use two smaller rectangles? Well, we could kind of go like this. We can find the area of this rectangle and then the area of this rectangle, and this should give us a better estimation than just using one big rectangle. Well, if we kind of see a pattern here, we could use smaller rectangles to get a better kind of fit for this shape. So if we had this little rectangle here, and then this one here, and this one here, and this one here, we're getting closer and closer to the shape. Now, if we keep making our rectangles smaller and smaller and smaller and smaller, skinnier and skinnier and skinnier, we can literally pretty much get the total area of this figure. And this is the main concept of integration in calculus. Basically, the main idea here is that we're going to take an infinite amount of little tiny little rectangles, if you will, and we're going to add them up. So here's a rectangle, and we're just going to add up an infinite many rectangles, and we will have perfectly found the area. Now, of course, from a practical standpoint, that's going to be kind of hard to get the area of all these tiny little rectangles. But the main idea of calculus, at least in terms of finding the area of figures, is really finding the area, or really finding the sum total of all the areas of these little rectangles. Now, of course, you're going to learn a lot more about this when you actually study calculus, but this is a real kind of main concept of a real big part of calculus called integration, and that's this symbol right up here. So when you see calculus, this thing right here is called an integral, and we're going to talk about what this means in terms of area right now. All right, so let's go down here and let's actually do an example problem and find the area of a shape that looks kind of like this. All right, so what we need to do is kind of put that shape on an XY plane. Now here comes some basic algebra. So we have an X and Y coordinate system in algebra, and we can construct a nice curve right here. Now the shape that we want to find the area of is this blue shaded shape right here that looks like this shape that we've been talking about with the rectangles. So here, this particular shaded area, we want to find the area of it. So what we need is a description of this curve, okay? And then we're going to need some points along the x-axis here. Now, if you don't know much algebra, just stick with me because you're going to see here that the math involved to actually calculate the area is not that difficult. But let's go ahead and take the next step here and take a look at how we can describe this curve. All right, so in algebra, we could graph this curve right here by this equation, y equals x squared. Okay, so y equals x squared is this U-shaped graph. This is called a parabola. So it goes like so. Now, along the x and y axis, there's these points. Okay, so in other words, it's just a number line. So we have 1, 2, here's 3, and there's 4, there's 5. And then we can go positive 1, 2, 3, 4, on and on and on, 1, 2, 3, 4, in all these directions. This is negative 1, actually. This is negative 1, negative 2, negative 3, negative 1, negative 2, negative 3. Again, as long as you have some basic idea of algebra, this should look somewhat familiar to you. So remember, the objective here is to find the area of this part underneath this curve described as y equals x squared. This is the equation to this graph. Now, you can actually construct the points on this graph by creating a table, an xy table. So when x is 0, okay, what is y equal to? Well, to get y, if I know what x is equal to, I would just plug in a 0 for x, so 0 squared is our y, so that's 0, 0. So that's the point right here, 0, 0. All right, when x is 1, what is y? Well, let's plug in 1 for x. Well, 1 squared is 1. So 1, 1 is on this graph. These are actually what we call coordinates. 0, 0 is a point on this curve. 1, 1 is a point on this curve. So here would be 1, and let's say that would be the point 1, 1. All right, so when x is 2, what is y? So we're going to plug in a 2 for x. So 2 squared is 4. So y is 4 when x is 2. So the point 2, 4 is on this curve. So here's 2, and this would be like 2, 4. So you can kind of basically play connect the dots and just list out a bunch of x points here, and then you can kind of construct this curve. So we're not talking about too difficult of mathematics here, and hopefully you are with me. Okay, so here is where we're at. Y equals x squared is the equation that describes this curve, and we want to find the area underneath this curve bounded by the x-axis. In other words, this shape right here. So this is what we want to do. We want to find the area of this shape. And we already discussed how we could kind of construct some rectangles to actually figure this out. But we're going to use calculus now to figure out the area underneath this curve from 2 to 3 on the x-axis. Okay. All right. So if you're with me so far, let's actually write some calculus here. And this is the way it will look. All right, so here is calculus. So calculus is going to say this little long thing right here is called an integral. Technically, it's called an elongated S, but you don't need to know that. But basically, it's the sum, or effectively what we're trying to do here is add up. You can think of this thing as add up all the rectangles between 2 to 3, start at 2, and go to 3. We're going to add up all the rectangles, the little skinny rectangles from 2 to 3 underneath the curve x squared. Okay, so that's what this calculus notation means. Let me go ahead and repeat that one more time. So it says add up, okay, all the rectangles underneath this curve x squared, start from 2 and go to 3, okay, on the x-axis. And when we add up all the infinitely small rectangles, we will have calculated the area of this shape right here, and that is the goal. All right, so if you're with me so far, now some of you might be saying, well, I kind of get what you're saying. Well, this video is intended to be a simple introduction to calculus. You'll learn a lot more about this when you actually take the subject, but at least you'll have some sort of appreciation of why we need calculus and some sort of understanding, a basic understanding of what this notation is saying, okay, this integral notation, and this is a very common, symbol in calculus. All right, so now what we need to do is actually calculate the area, and again, we're not going to need to know much math. We're going to be talking about some basic fractions, really, in order to calculate the area. All right, so let's go ahead and get into that right now. So the area underneath that curve, okay, and we're talking about this little crazy shape right there, is going to be equal to this thing right here, this integral from 2 to 3 x squared dx. Now, some of you might be saying, hey, Mr. YouTube Math Man, what does this dx thing stand for? Well, that's for another video, and that's really not so important at this level of calculus. This is important, obviously, for those of you that will actually take the subject. But for what we're doing here, we can kind of disregard that dx, but that is part of the notation to actually write this problem out. Okay, so we need to figure out what this thing is equal to, this integral x squared. All right, so I have the answer right here. It's x cubed over 3. Now let's talk about how we do this, okay? All right, let's pay attention to this x squared, and we're going to do this integral of x squared, and the answer is this. So all we do, let's focus in on the x squared right here. Okay, here's x squared, is we're going to add 1. There's a rule, okay, there's actually a lot of rules in calculus. They're not that difficult to follow. It's just a bunch of rules you need to learn. So in this particular situation, the rule says just add 1 to the exponent. So here, this is 2, okay? So we're going to add 1 to 2. All right, so 2 plus 1 is what? Well, that's 3. So the rule is add 1 to whatever this power is, and this exponent, so that's 2. So we're going to get x to the third power. Now, whatever the answer is, the exponent, divide by that, okay? So that is what the rule says. So we have x cubed divided by 3. So once again, let me go ahead and explain this. We need to do this little integral here. So we have x squared. So once again, we're just going to add 1 to the power, whatever that's equal to, we're going to divide the entire thing by. All right, so we're going to end up with x to the third power. We're going to divide by 3 because that's what we got up here. All right, so we are almost there. So all of this, okay, we haven't even calculated the area, but we did take care of this integral part. This integral x squared is equal to x cubed over 3. Now we can actually calculate the specific area to this shape. All right, so let's go ahead and do that right now. And what we're going to do is the following. So here is our integral, right, which means add up all those skinny little rectangles or find the area underneath this curve from 2 to 3. And what we're going to do is take our answer to doing this integral, which is x cubed over 3, and we're going to subtract it from itself. Okay, x cubed over 3 minus x cubed over 3. This is how we do this in calculus. Whatever we did here, we're going to actually subtract it from itself, but we're going to plug in the top number on this integral right here. Okay, so we're going to replace this x with 3 on this first one. Okay, so this x is going to get replaced with the 3. And then on the second one, this x is going to be replaced with a 2. And when we do this number crunching, we will have actually calculated the area of this shape. Again, I'm not doing I'm not doing a lot of advanced algebra or anything else. And you're going to see here where what we're really going to be doing is just a bunch of fraction work. So as long as, again, if you have some basic math skills and basic algebra knowledge, you should be able to kind of follow along on what's going on in terms of this calculus problem. Now, before we continue on, if you want to get better at math, you definitely can. But the key is to find a teacher that gives you clear and understandable instruction. So hopefully you like my teaching style, and if you do, if you're like, yes, I think I can learn from you, well then you will love my full main math courses. So you can find the links to all of these courses in the description, but they include basic math, pre-algebra, algebra 1, geometry, algebra 2, pre-calculus, and a ton of specialized test prep math courses. Okay, so again, don't give up if you're having a tough time in math. I can definitely help you out. So you can check out the links to all these courses in the description. So let's get back to the video. Okay, so here is our x cubed over 3 minus x cubed over 3. Remember, we're going to plug in that top number on the integral, which was 3, in this first x cubed, and then our bottom number, which is 2, we're going to plug it in on this second one. So here is the setup. So we have 3 cubed over 3 minus 2 cubed over 3. And let's go ahead and do the number crunching right now. So 3 cubed is what? That's 27. 3 times 3 times 3. So 27 over 3 minus 2 cubed, which is 8. 2 times 2 times 2 over 3. So when we do this simple fraction subtraction problem, we have 19 over 3, which is the answer. But if you take 19 and divide it by 3, effectively what you have is 6.3. And that is the answer. That's the actual area of this little shape underneath this curve x squared. So that is a precise area, 19 over 3. And, some of you might be saying, wow, that's kind of, fascinating. And hopefully, you weren't, overly, well, let me just say it this way. You weren't overwhelmed with the amount of math to actually calculate the area of this crazy looking shape underneath this curve. And that was kind of the main idea of this video, was not to overwhelm you with all this advanced math. Okay, I tried to explain this in a way where pretty much anyone can understand. Even if you didn't understand it perfectly, hopefully you have some sort of sense of what calculus is about, at least a big part of calculus, which once again is to find the area and volume of shapes where we don't have lovely little simple formulas for, like a rectangle, a square, a circle, a triangle, etc., etc. Okay, so once again, in mathematics, you're going to come across symbols and notation that if you don't know what they mean, they're going to tend to, intimidate you in the sense that you're going to be like, oh, this is too hard. I'll never be able to figure it out. Well, what you have to do is just take on these new symbols that you encounter in math one at a time. And more often than not, you're going to find out that they're really not that bad. Okay, so if this video was interesting, or if some way it inspired you to maybe want to learn calculus, make sure to like and subscribe. And with that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.